Good evening, sports fans. I mean, math enthusiasts. Hey, y'all, I have a floor problem tonight, which is kind of a floor problem in reverse. We're actually given the floor value of an expression. We're given that it's equal to 1967. Y'all remember the floor function always maps to a natural number. And so that's it. It's a mapping from real numbers to some natural number. In this case, natural numbers in general to integers. And I have a little lemma here that's kind of handy because this does deal with the square root of a pretty long expression. And it kind of cuts down on some of the arithmetic you have to think about. So let's go ahead and jump into it real quick. Now, y'all, this lemma here is quite useful. Let me just, I have an example here. This says the floor of the square root of x is equal to 2, provided that x is trapped between these two numbers. And notice these two numbers are just perfect squares. 4 is equal to 2 squared, and 9 is equal to 3 squared, okay? Now notice we have to exclude 9 because otherwise, I'll write it down. The floor of the square root of 9, and y'all remember the floor just sends an integer to an integer. Its job is to send numbers to integers. It's called the greatest integer function, but the floor of the square root of 9 is equal to 3. All right. And just to make sure it's making sense to you, the floor of the square root of 8 would be equal to 2. And it's just based on the fact that the square root function is an increasing function. All right. So anywho, this lemma is kind of a significant part of this problem. Now we're supposed to find the maximum m natural number. Natural number means 1, 2, 3, 4, 5 ad infinitum, such that we maintain a floor level of 1967. Okay, maximum m such that we maintain a maximum floor level of 1967. Now, I kind of played a dirty trick on you on this one. You need to notice this looks like a very strange number until you remember, well, 8 times 7 is 56, right? So this number turns out to be a very nice number, in fact. 80 times, I'm trying to put a hard multiply, that's a dot there to connote multiplication. So 80 times 2007. Okay. Okay, y'all, that reads 80 times 2007. Now that comes into handy on this very next line here, because you can see where the 1967 is coming into play already. 2007 minus 40 is 1967. And this is just a very well-known difference, binomial difference squared, I guess how you say it. All right, so squared, this is certainly equal to a squared minus, I'm trying to keep it lined up, folks, minus 2ab, okay, plus b squared. All right. So that's pretty slick there, and you can see the magic here with the 2 times the 40, right? 2 times 40 is 80. We've already seen that 80 times 2007 is 160,560. Now, of course, 40 squared is equal to 1,600. And I do want to note that this is just 1967 squared right here, right? 1967 squared. Okay. And so for m equals to 1,600, we get that the floor of our original expression is equal to 1967 as desired. But that would be a minimum, okay? It's certainly not the maximum, because you see you have an entire range of numbers. Like here, there's an entire range of numbers where the floor is 2. Well, it's the very same for this. Right here, this would be 1967 squared and 1968 squared as far as this lemma goes. 1967 squared, 1968 squared, and notice we're excluding the k plus 1 squared. All right. Now, so we got to carry on. Now, the best way to manage this thing is just to notice that the difference of these two squares, 1968 minus 1967, 1968 squared minus 1967 squared is equal to this 3935. And that follows from the difference of two squares. If you want to use a calculator, that would be A plus 1967 quantity times A minus 1967 quantity. So you see 1968 minus 1967 is 1. And so you do get 3935, which is just turns out to be the sum of 1968 and 1967. Okay. Now from this truth, we can rewrite 1968. You know, if you rewrite this, how do I have this written down here? Yeah, if you bring this to the other side, you can write down 1968 squared is equal to 1967 squared plus 3935, and then just put square roots over both of them. Okay. And so we get that this has to be equal to 1968, right? Because the square root of 1968 squared is take the floor of that is just 1968. All right. Now here's where the next bit of magic. This is still equal to 1968, but that's the lowest value. Okay. Again, that would be like 1968 squared on this end. It would be your lowest value in this lemma for the floor levels. Notice that we just decrement it by 1 here. See, this is 3935 minus 1 is this value right here. And you notice how that knocks this floor level down to the next floor level. And that's really the magic, along with noticing that 80 times 2007 is this number right up here. Okay. And so you get the M by adding the 1600 to this value 3934, and you get 5534 as your answer, folks. Now, you guys, you can check it out if you want to. Go ahead and plug it in up here, and if you want to, drag out your calculator, and you'll see that you get a number very, very close to 1968. It's like 1967.99999, and so this does satisfy the requirements of the problem. It is the maximum value of M that'll maintain this floor of 1967. Hope you enjoyed. Let me know what you think.